there still is time, but you know, if you can complete them now, please do so. Wait to stop the transcription. Okay. All right, I think we're good to go. All right, I'm going to share my screen. And today we are going to move on to the next learning unit, which is probability distributions. Okay, all right, so before I kick things off, let me just open the whiteboard, and I'm going to show you by an example what this learning unit entails. All right, so I'm making the assumption that everyone is up to speed with last week's session, and it's very important that you are, because this learning unit builds on that. Okay, so in last week's session we covered probability, and we explained you know, how you would use that in the real world and how to actually interpret it. Now, in this learning unit, what we're going to cover is probability distributions, and what probability distributions are. You can think of it as a shortcut to work out probabilities for specific type of problems. All right, and there are 3 methods to work these probabilities out. So I'm just going to write them here. In this course, you're going to cover the binomial, and I'll explain each of them when we get there. Right, so the binomial distribution, there's the Poisson distribution, and lastly, there's the normal distribution. Okay, so in this learning unit covers all 3, but today we're only going to cover these 2. Okay, so next week we're going to continue with this learning unit, and we're going to do the normal distribution next week. But today we're going to do these 2. And the reason why it's split up is because the binomial distribution and the Poisson distribution deals with data that's discrete. And what I mean by discrete is when we're counting something. Okay, so a discrete random variable, all you need to know for that, I'm just going to write RV for random variable, is when you're counting something. So your x variable can only take on values like 1, 2, 3. It can't take on values like 2.5, 3.75. It can't take decimal values. So for instance, if you're trying to measure how many customers would come into a store in a given day, you would never have 2.5. Okay, you'd always be counting whole numbers. And these are known as discrete random variables, and the binomial distribution and the Poisson distribution deals with a discrete random variable. Right? The normal distribution deals with continuous random variables. So in other words, the values can take decimals. Continuous random variables. So you can think of maybe temperature. Maybe X in this case is measuring temperature, which can take decimal values, like 2.5, 31.7, etc. And that's what the normal distribution will cover, continuous random variables. So we're going to deal with the binomial and the Poisson distribution today, which deals with discrete random variables. So I'm just going to clear this, and I will check the chat if there's any questions before I move on. Okay, so it's just important that you understand the difference between a discrete random variable and a continuous random variable, right? Because the moment you know it's a discrete random variable, and you know that it can only be a binomial distribution. Okay, it can only be a binomial distribution, or it can only be a Poisson distribution. So I'm just going to write this here, and Poisson. Let me just check the chat. When are all the ICE tasks due? Taya, I hope I'm pronouncing your name correctly. The first ICE task, I believe, is due on the 30th of April. But the other 3, they due a bit later. I'm not 100% certain on the date. I do know it's in May, but I don't know the date exactly. But do try and complete all of them this month. Okay. Hope that helps. No worries. Okay, let's get back to the whiteboard. All right, so let's look at this problem to kind of help explain these probability distributions. So what this problem says is, once a week, a merchandiser replenishes the stocks of a particular product brand in 6 stores. So I'm going to underline certain values because we're going to come back to it. So there are 6 stores, right? And this is what she is responsible for, to replenish stocks in these 6 stores. So experience has shown that there is a 1 in 5 chance. In other words, this 1 in 5 chance, that's a probability. So, oops. Underline that. The 1 in 5 chance that a given store will run out of stock. So that's the probability that a store will run out of stock, right? So the first question is, which probability distribution is appropriate and why? Okay, so what you need to know for binomial distribution is, firstly, read through the question and try to understand, are there only 2 possible outcomes? And what I mean by that is, if you read through this problem, what they're interested in, if you look at any of the questions, is what is the probability that on a given weekly round, the merchandiser will find exactly 1 store out of stock? And if you read the other questions, it's saying the same thing. So basically, what we're kind of interested in is just 2 possible outcomes, which is out of stock and having stock. And they're the opposite of each other, or they're the complement of each other. In other words, think of flipping a coin and either have a head or a tail, right? So it's the same thing with this. You can either not have stock, so out of stock, or you can have stock. And these are complementary events. What I mean by that is, if you knew the probability of one of them, say for instance this was 20%, then this would have to be 80% because they both must add up to 100%. It's the same thing as flipping a coin. If the probability of having a heads is 50%, then the probability of tails must be 50% as well, because they must add up to 100%. That's what we mean by complementary events. They are the opposite of each other, and their probabilities add up to 100%. So that's the first thing we check. There's only 2 possible outcomes. And the other thing you want to look for is, are there a fixed number of trials? And what I mean by fixed number of trials, if you look at this question, are there an endless amount of stores? No. There are 6 stores, so there's a limited amount of stores which this person is responsible for. So there are 6 possible outcomes. 6 trials, so 6 experiments. 6 experiments or trials, it's the same thing. So there's a limited number of trials. If these 2 conditions are met, if there's only 2 possible outcomes, if there is a limited amount of trials, yes, there's only 6, then that means you use a binomial distribution. Okay, remember that. If these 2 conditions are met, then that means you use a binomial distribution. There is an additional property. I just think I'll mention that. But for now, if you can just figure out these 2 things, if these 2 things are satisfied, that's good enough to know that you need to use binomial distribution. There is a third criteria, and that's this. This would only be necessary if the question asks you to state your reasons and why. The third reason, so this is the first reason, this is the second reason. The third reason is each trial is independent. What I mean by that is, if you look at what this question is saying, okay, they're trying to determine whether a store will be out of stock or have stock. Now, if you have store 1 here, let's call this store 1, and there's store 2. There's no information in this problem to say that if this store is out of stock, then this would influence store number 2. Okay, they have no bearing on each other. So if, say, the store 1 was in KZN and store 2 was in Gauteng, they are independent of each other. Whatever happens in one store doesn't really influence the other store, unless they tell you that in the text, but they don't say that. So in other words, they are independent. So that means there are independent trials. These are the three reasons why you would use a binomial distribution. But if you just can figure out these two, it's good enough to know which distribution to use. Now, a little advice I can give you is, if you know the conditions for why it would be a binomial distribution, it isn't extremely important that you know the reasons why you would use a Poisson distribution. All you need to know is, if any of these aren't satisfied, then that means you use a Poisson distribution. Okay, so if you just understand when to use a binomial, then if any of these reasons aren't satisfied, then that means you would use a Poisson distribution. Okay, is that clear? Remember, you first need to determine whether it's a discrete random variable. That is, are you counting something? If it is yes, then you know we need to use any of these two. Okay, then we move to one step further, and then we look at, are any of these conditions met? If one of them is not met, say this one is not met, then you know you need to use the Poisson distribution instead. Let me just go to the chat. It's very important you understand this, because if you get the wrong distribution, and this section carries a lot of marks. Say the question is requiring you to use the binomial distribution and you use the Poisson distribution, you will get marked 0 for it. Okay, so it's extremely important that you understand how to differentiate the two. So I'm going to take it as a yes because I have no questions so far. But if there's anything you're not sure about, now is the time to ask. Okay. I'm assuming. Thanks, Austin. Thanks, JD. Okay. Let's move on. All right. Now that we know this problem does have two possible outcomes and there's a limited number of experiments, we know it's a binomial distribution. All right. So now I'm going to clear out untidy writing. We're going to get started with the calculations. Yep, Poisson. Okay, so now we're dealing with a binomial distribution. So the top, and you don't need to memorize this formula here. Formula sheet. Excuse me. It's just important you understand how to use it. So I'll write it a bit larger so you can see it. But basically, the formula is P of x equals n cx, p to the x, an exponent, into 1 minus p to the n minus x. That's what this formula is. Okay, all right. So we've answered the first question, which probability distribution is it? It's the binomial distribution. All right, let's move to the next question. Now the question says, what is the probability that on any given weekly round, the merchandiser will find exactly one store out of stock? Okay, so I'm gonna just underline something there. Okay, so remember what we said. X is a discrete random variable and we're counting things. What exactly is it counting? Well, if you read the text, what we're trying to count is the number of stores out of stock. So X, right, is the number of stores out of stock. Okay, that's what our X is. And so what the question B wants us to answer is, what is the probability that X is equal to 1? So it's saying, what is the probability that one store is out of stock? So they're asking us probability of X equals 1. That's what they're asking us, and we need to figure this out. And how we do that is by using this formula here, right? And now we just know what are these values in the equation. What's the n, the c, the x, and the p? Right, so let's start with x. We already know x. It's what the question asks us for. So we're going to substitute 1 for x. Wherever we see the x, we are going to substitute 1. Okay. The n is the number of trials. So in total, how many stores do we have? Okay, so we only have 6 stores. That's why we highlighted this part or underlined it. N is equal to 6. And then there's one more symbol we actually need, right? We'll ignore the C for now because it actually isn't a value. It's what we did last week. So I'm just gonna put a little underline here, because this thing that I'm putting under, underlining, is a function in your calculator. So the P is the probability of what we're trying to measure. So we're trying to measure the number of stores out of stock. So there needs to be a probability that a store will be out of stock, and that's what your P is. And if you read the question, it says experience has shown that there's a 1 in 5 chance that a store will be out of stock. So it's 1 in 5, or in other words, 20%. You can leave it as a fraction if you want. You can write it as a decimal or percentage. Either way is fine. Whatever works for you. Okay. All of it is acceptable. The important thing is, in the final answer that we work out, we express that as a percentage. I'm just going to check the chat for any questions. Okay, nothing so far. All right. So let's get back with okay, so let's work this out in our calculator. Right? So what we have is all the values we need to plug into this formula here, right? So remember, n is 6, so it's going to be 6 plus c, and then our x is 1, and then it's times. Remember, there's multiplication between each thing. Okay, so it's times p, and that's 0.2 to the power x, which is 1, into 1 minus 0.2 to the n, which is 6 minus 1. That's what our x is. So what this is in your calculator, what we did last week. If you look at your calculator, and if you look at the division button, you'll see above that, you will see this notation, NCR. It is the exact same thing what we're trying to do here. It's just instead of R, we have X, but it's just notation. So that means instead of R, we're going to use the value for X, which is 1. So we would punch all of this into our calculator, right? And you can do it now as an exercise while I'm doing it. If you put it all into your calculator, all right, with the brackets and the exponents, etc., you'll get a value of 0.393. I'll just stop here at the fourth decimal. That should be good enough. 3932. All right, which is 39.32%. Okay. Anyone's uncertain about something? Just going to check the chat. Okay, all good. All right. So it's very important that you become comfortable with your calculator. Okay, you need to be able to work out these probabilities using the combination function. All right, so that's question B answered. Okay, it is 39.32%. Right, so let's move on to the next question. Clear this out. Yes. Okay, so the next question, C, is what is the probability that at most 2 stores will be out of stock? So at most, so let's at most 2 stores will be out of stock. So we know that X is the number of stores out of stock. Okay, so I want you to put this in the chat, okay? I need to test how you're understanding interpreting question C. Are they asking for probability of X being greater than 2? So are they asking for this option, or are they asking for option number 2, probability of X less than equal to 2? Which of it are they asking for? Can you put your option in the chat? Are they asking for option number 1, or are they asking for option number 2? Very good. Everyone says option number 2. Excellent. That's right. They're asking for option number 2. All right. And it's very important that you understand that. Okay, so they're saying at most 2. So when you say at most, that means you can go up to 2. You would include 2. If you're not 100% certain of that, what you can do is you can write out all the X values that you think they're asking for. So they're saying at most 2 stores. So at most, you can have 2. You can't have 3. You can have 1. You can have 0 as well. Remember, you can have no stores being out of stock. So 0 is a valid value for X. So that's what they're asking us for. They're asking us for X being 0, X being 1, and X being 2. So there's 3 probabilities they're asking us for. They're asking us for all of them. And so the final answer would be actually working out each of them, X equals to 0, plus probability of X equals 1, plus probability of X equals 2. You'd have to work out each of these 3 probabilities and then add them up, and that's your answer. That's pretty much it. So it's just a little bit more work than what we did in the previous question, but it's the same approach. Each of them you solve by using this formula here. It's just that when you're working on this probability, you're going to put 0 in place of X, but everything else is the same. When you work out this probability, you're going to use X equals to 1 in this formula, okay? And then this probability, you're going to place X equals to 2 in it. And you're going to work all of them up, and then you're going to add it up. And if you do that, I'm just going to give you the final answer. I won't do each one because if you understand the question before, it's the same method, right? It's just that you have to add up all of those probabilities. When you add them up, you get a value of 90.112%. That's the answer. Okay, 90.112%. Let me just check the chat. Any questions? Okay. But I'm glad everyone understands how to write that inequality. What I mean is you understand how to write this part here out. It's very important that you're able to do it. All right. So this is known as a cumulative probability because you're not just working out the probability for one value of X, you're working it out for a series of X values and then you're adding up the result. Okay. So that's question number C. Question number D. Let's get to that. Question number D, you just need to write it up mathematically and then doing the calculator work after that. So if you look at what we declared X as, X is the number of stores being out of stock. And question D is saying, what is the probability that no stores will be out of stock? So what they're saying is, find the probability that X is 0. That is no stores being out of stock. That's all they're asking for. So all you need to do is use this formula, but substitute 0 for X. Okay, you're going to substitute 0 wherever you see X, and then your P and your N remain the same. And if you do that, you get a value of 0. I'm just going to write it as a percent, which is 26.21%. So what I'm going to encourage you to do is, when you watch the recording, so even if you're working on these probabilities now with me, great. But if you want to do some revision and recap this work, then do the calculated work and check that your answers correspond to mine. Okay, then you're using your calculator correctly. If you're not getting the same answer and you're struggling with it, contact me. I can walk you through it. All right, so do these as exercises. Okay, so that's question number D, 26.21%. Now the last question is the mean number of stores. So the mean number of stores that will be out of stock each week. Okay, in other words, the mean is the average. Okay, the average. I'll go to the chat if there's any questions and I'll come back. All right, so before we do this average, okay, let me ask you this question. And we actually looked at this question last week about flipping a coin. Right? Let's say the coin is fair. That means the probability of getting a head is the same as getting the tail. Okay, so we have a probability of getting a head, which is the same as the probability of getting a tail on a coin, which is 50%. Right? Now let's say I flipped the coin 10,000 times. So I flipped it 10,000 times. So my number of experiments, n, is 10,000. Okay. What is the approximate number of heads you would expect to get? If I flipped it this many times, 10,000 times, how many heads do you expect to get? Can you write that in the chat? Remember we covered this last week? You may not even need to cover that. Just think about it. There's a 50-50 chance of getting a head, and you flip the coin 10,000 times. Roughly, what amount of heads would you expect to get? Very good. Excellent. Now, how you're getting that is you're actually taking this probability ahead. We'll call this P, right? You're taking this P and you multiply it by N. So P times, I'm writing it the other way. It's the same thing, but I just, it's a bit finicky in this. It's N times P. In other words, what you're doing is you're taking the 10,000 and then you're multiplying it by this 50%. That's what you're actually doing. And if you do that, you'll get your 5,000, which is what you're putting in the chat. So that's pretty much how you're getting that 5,000. You're working out your N times P, and what you've actually worked out is the average number of heads you would get. That's what you've worked out, the average number of heads. So in that same philosophy, okay, now instead of flipping the coin, we don't have a coin. We have the probability of a store being out of stock, right? So we have our P, the probability of a store being out of stock, as being 20%, 0.2, right? And our N is not 10,000. Your N is 6. You only have 6 stores. So on average, the number of stores you would expect to not have stock would be N times P, exactly like what you just did. So it's 6, that's what our N is, times 0.2, and if you work that out, it's 1.2. That's what on average you would expect for the number of stores to be out of stock. Does that make sense, everyone? Someone could just give me a thumbs up or say not making sense. Please, I'm happy to go back and explain it if it's not making sense. Okay, so far so good. Redo, Boston. Okay, all right. So if you, let me say, let's just use another example, right? Let's say, let's say you played a game, okay? There's a game that you're playing, and the chance of you winning, okay, the probability of you winning, let's say it's 5%, okay, or 0.75. Let's say the chance of you winning is 0.75. All right. Now, let's say you played this game 10,000 times. You played this game 10,000 times. Okay, if you played it 10,000 times, on average, how many times do you think you would win if the probability of winning is 75%? And if, let me know if this makes sense to you. If there's a chance of winning of 75% and you played the game 10,000 times, you would expect to win on average 7,500 times. How did you get that? Well, it's basically 0.75 times 10,000. That's how you get it. So Austin, does that make sense? Before I move on, it's important that that concept makes sense. Yeah, you wrote it. Okay, so you got it. So that's the exact same thing I'm doing. That's all I'm doing right now. Now, instead of the winning, I have a probability of a store being out of stock. So think of your probability of winning as being 0.2. Okay, that's your P. That's the probability of store being out of stock. And instead of 10,000 trials, we weren't given 10,000 stores. We were given 6 stores. Okay, so now 5, you got 6 stores, and you get 1.2. You expect 1 stock. Austin. Okay. Good question. All right. The binomial distribution. Okay, that's all I want to cover for the binomial distribution. Now, Poisson distribution. All right. So a Poisson distribution is also a discrete distribution, as I mentioned earlier. But the difference is that for Poisson distribution, what you're trying to count is something occurring within time intervals. Okay. So let's look at this problem, and I'll kind of explain it using this problem here. So what it says is a web-based travel agency uses its website to market its travel products. Right? The agency receives on average 5 web-based inquiries per day. So let's underline this part here. On average, 5 web-based inquiries per day for its different travel products. So what they're saying is, look, this is 1 day. Here to here, that's 1 day. That's day 1. And they have, let's say the first day they got about 6 calls or inquiries, should I say. The next day, day 2, they got about 4. The next day, okay, they've got about 7. The next day it's 3. Okay, it changes a bit, but roughly on average, if you did this for the entire month and you just worked out the average per day, it's about 5. Okay, so what we're doing is we're counting the number of occurrences of something happening, and in this case, it's web-based inquiries. So they're counting the number of instant interval is a day. When you're trying to work out the probabilities of this type of problem, where you're counting the number of occurrences within a time interval, then it's a Poisson distribution. Right? That's what you pretty much need to know. If you're given an average occurring in a given time interval, right, that is a giveaway to use a Poisson distribution. All right, and for the Poisson formula, you're going to use this formula here. So you don't need to memorize it. It's in your formula sheet, but I'll take you through how to use it. It's e to the minus a times a to the x all over x factorial. Okay. All right. So let me just check if there's a question before I move on. Okay. All right. Now this x with the exclamation mark, right? That's known as x factorial. All that is, okay, it's very, very simple. If I have 2 factorial, all it means it's 2 times 1. If I have 3 factorial, then it means it's 3 times 2 times 1. Right? So you get the idea. If it's 5 factorial, then all it means it's 5 times 4 times 3 times 2 times 1. So instead of writing it all out like that, we use this notation to kind of compress it to make it simple. But that's all the factorial means. So whatever value you put for x, if x was 5, then that's what 5 factorial is. That's all it is. Okay, but don't worry, you won't have to enter it like this in your calculator. Your calculator actually has a factorial function, so it makes your life a lot easier. You wouldn't have to put 3 times 2 times 1. You just need to tell the calculator 3 factorial, and I'll show you how to do that, and it'll give you the answer. All right, so just to heads up, that's what factorial means. All right. Then we'll get to the numerator in a bit. Okay. Well, let's look at the first question. Question A. Right. It's saying, what is the probability that on any given day, so it could be this day or this day, doesn't really matter, but they just want to know on any given day, right, the agency will receive only 3 web-based inquiries. Okay, only 3 web-based inquiries. All right, so remember, we're counting something happening. That's what discrete distributions do. And what we tend to count is the number of inquiries. So that's what our X is. Now X is the number of inquiries. Right? That's what our X is. And so A is asking us for what is the probability that X is equal to 3. They want to know what's the chance of getting 3 web-based inquiries. Does that make sense, what I've formulated here? Oh, good. Before I get into the equations and the calculator work, I just want to check that everyone's all good with the equation. Okay. All right, just let me know otherwise, okay? All right, so that's what we're trying to work out. So like I said, we know that we're going to use the Poisson distribution, so that means we use this formula here. Right? Now you'll see in this formula, things we need to know is A. What is A? All A is, it's the average number of instances we have in that time interval. That will be given to you in the problem. So if you read the problem, it says the agency receives on average 5 web-based inquiries. So that's what your A is. It's 5. So we know our A, and the X is just what they're asking us for in the question. So your X is 3. So we're going to plug in 3 where we see X. The E isn't really a variable. It's actually a number. It's like how you have pi. Think of it like that. It's actually a number, and it's in your calculator. Right? So that's what your E is. So let me show you how to do it in your calculator. Right? So what you can do is you can press the fraction button. Right? You'll get this. You'll see this button here. So firstly, your calculator should be off stat mode. Right? If you want to take it off stat mode, press mode. Right? Press mode and then choose comp. But then you can do fractions. All right? So first do that. Once you've done that, then you can press the fraction button. And you'll see which is this button here. Right? And when you do that, then you basically see that it's asking you to enter something for the numerator. All right, so what we're going to do in that numerator, okay, is we're going to look for a button that's like this. It's on your far right. It's the ln, the natural log button. And if you look above it, if you look above that button, there's an e to the square there. And what we want to do is we want to use that function there, because if you look at this formula, it's the same thing. It's e to the something there. All right, so you're going to press, once you've got this fraction and your cursor is blinking here, you're going to press shift, and then you're going to press this button here. And you'll see that it's going to give you e to the something, and you need to tell it what you want as the exponent. Okay, so you do that. Okay, you do that, e to the something, and what we're asking for is minus a. But our a is 5, so what we're going to enter is minus 5 here. Minus 5. All right, and now be careful because your cursor is still blinking on the top here. So whatever you type is going to remain on the top, and you don't want that, because now we need to move back down to this part. Okay, so what you do is on your cursor, or the button with all the arrows, move right. If you just move right, the cursor moves back down here. And remember, the next step is the multiplication. So you're going to press times. Okay, you press the times button, and then it's a to the x, and our a is 5. Okay, so a is 5, it's 5, and our x is 3. And we've done exponents in the previous session, but if you're not sure how to get exponents, that x with a block on the top. That's how you get the exponents. Okay, so you press that, and you'll see it's asking for the exponent, which is 3. So now you've finished the numerator, and now you need to move to the denominator. And then to do that, just use your cursor to move down, and it's going down to the bottom. All right. Once you're here and it's blinking, okay, now you need to capture what's in the denominator, and I'll show you how to do that. Okay, now remember, we want to capture we want to capture 3 factorial in the denominator because that's what it's asking for. X factorial, no, X is 3. All right. So how you do that is if you press 3 first, give me a second, I'm looking for my factorial button. It is there. Sure. One second, class. I'm trying to figure out where the button is. Ah, there it is. There's a button. I'll show you this. On the top right, you'll see a button like this. It's x to the minus 1. And above that button, you'll see it has x exclamation mark, which is exactly what you're seeing here. So what you need to do is, in order to access this, you're going to type, let me take this block out. You're going to type 3, then you're going to press shift, then you're going to press this button. And you'll see there's an exclamation that pops in there. And then you're done. And you press equals to, and you get your probability. 0, which is 0.1404. Let me just check the chat. Okay, well done. Okay, so is this calculator work? This requires you practicing with that. Okay, so it's very important you understand how to access this exponent, okay, and how to use the factorial button. All right, that's pretty much what you're going to be using for the Poisson probabilities. So you've got to be comfortable using your calculator to use those functions. All right, so that's question number A. I'm going to move on to question number B. All right, question number B. All right. It's asking us, what is the probability that on a given day the travel agency will receive at most 2 web-based inquiries? So this is the same kind of question we had for the binomial distribution. At most 2 means probability of x less than equal to 2. That's what they're asking us for. So in order to work this out, we need to work at the probability of x equals to 0 plus the probability of x equals to 1 plus the probability of x equals to 2. You need to work at each of them. Oh, sorry. Two. All right, and then once we get each of them, doing what we just did before using the calculator, we add the values up. Okay, and if you do that, we'll work out each of them, just like how I showed you earlier. Remember, we worked out the question for this, we already worked this one out. Okay, to 0.14. Sorry, did we work this one? No, sorry, we did 3. Take it back. We didn't do any of these. But just to give you an idea, maybe I'll write these out so you can compare to when you're using your calculator. So for the first one, it's 0.0067. For the next one, it's 0.0337, and then it's 0.0842. Okay, and then once you got them all, you add them up, and your final answer, okay, is 0.1247. So now it's 12.47%. That's your final answer. Okay. Let me check the chat. Any questions? All good? Everyone? I can get a thumbs up or yay or nay. Thanks, everyone. All right, the last one we're going to do. Okay, so probably this is the trickiest one. which is unfortunately saved for last. So I really need you to focus on 100% and put your thinking caps on. All right. So if anything is unclear when I'm explaining this, you have to let me know. All right. So let's clear this out, and then I'm going to read through the question. So now for question number, so we've answered B, we've answered A. Question C is, what is the probability that the travel agency will receive more than 4 web-based inquiries? So more than 4. So more than 4 means you don't include 4, all right? So it means probability of X greater than 4, okay? It's strictly greater than. More than 4 is the same thing as greater than 4. So what they're asking us is, more than 4 means 5. I'll just write it here. It means 5, 6, 7, 8, etc. So in other words, they want me to work out the probability of X equals to 5 plus the probability of X equals to 6 plus. Now the thing is, there is no end to what X can be. You can have an infinite number of inquiries in a given. There's nothing to tell us where to stop. And that's a problem, because there is no way you are going to work out all of these probabilities in a given amount of time. All right, it will take you forever. So we need to find a way to work this out in a more efficient way. All right, and how we're going to do this is we're going to use the complement rule. Now, what the complement rule is, it's pretty simple. Remember, let me ask you this, right? And we're going to use this understanding to explain it. If your probability of winning is 60%, right? And I want you to write this in the chat. What is your probability of losing then? What do you think it is? If your probability of winning is 60%, then your probability of losing is what? Very good. Excellent. All right. That is exactly it. Now, that is 40%. And you know, you may not even have given it much thought, all right? But how you actually work that out, what you actually did is, I'm just going to clear this out. A second. All you did was to work out the probability of losing. You simply did 1 minus the probability of winning. That's what you did. So 1 minus 60% gives you 40%. That's what you've done. You used what we call the complement rule. The complement, all right? Now, keep that in mind, okay? So just keep that reasoning in the back of your mind when I explain this. So instead of, I'm going to make this less complicated. Instead of saying X greater than 4, okay? I'm just going to call it A, right? And then the opposite of A is we do this. We call this complement. All it is if you win here, that's you're losing, right? So in general, the complement of anything A will be not A, and we write it mathematically like this. That's all it is. I could have wrote, instead of writing L, I could have wrote this, a W with a dash on the top. It means the same thing. It means not winning, when other words losing, okay? So just remember that, okay? It's just math notation. So if this X greater than 4 is A, so in other words, if this is probability of A, and I want to know probability of A, then in the same way we just did earlier, I can work it out by taking 1 minus the probability of not A. So in other words, I want the probability of winning. Sorry, I did earlier. If I want the probability of losing, then all I need to do is work out 1 minus the probability of winning. It's the exact same thing I did. So if you want the probability of A, you just need to work out 1 minus the probability of not A. Does that make sense? Check the chat. Good? Okay. All right. So that's what I'm going to do here. I'm going to let this entire thing here in the bracket, instead of saying x greater than 4, I'm just going to say a. I want to say, call it a. So if I want the probability of a, I need to work with 1 minus the probability of not a. That's what I want. Now, this is where that x greater than 4 is going to come in. If a is x greater than 4, if a, I'm going to put a line here, if a is the event that x is greater than 4, what is the opposite of that? Is it this? Is it option 1? Is it x less than 3? Is it option 2, x less than 4? Or is it option 3, x less than equal to 4? Which of these options do you think it is? Is it option 1, option 2, option 3? What I'm asking is, which of these is the complement of this? Which is the opposite of this? Which one do you think it is? Remember, if you got x greater than 4, that means 5, 6, 7, 8. So in the opposite, it should have 4 in it. Because if a doesn't have 4, that means you got 5, 6, 7, 8, etc. Then the opposite must include 4 and below. So which of these options, option 1, 2, or 3, is the opposite? Very good. Excellent. Very good, everyone. Option 3 is the opposite. Yes. Well done. Nicely done. So that is the opposite. So now instead of saying not A, I'm going to replace it with the option that you chose. It's x less than or equal to 4. Very good. That's all it is. That's how you use the complement rule. Okay? This can work out, but the thing is it'll take you just too long. It's not practical. So you have to use the complement rule to do it. And the thing is, for the complement rule, this we can work out. Okay? It's only 0 for x equals to 0, 1, 2, 3, and 4 that we need to work on. We just need to work out these 4 probabilities. And that we can do in a reasonable amount of time. So this is simply just working out the probability of x equals to 0, x equals to 1, x equals to 2, x equals to 3, and x equals to 4, and then adding them up. That's what we've been doing all this time. Like the question we did before this, right? Cumulative probabilities, that's the same thing we're doing. We do that, and if we do that, we'll get a value of, so don't forget this 1, we're just going to bring this 1 minus down. So next time, 1 minus. If we do what I just told you here, working out each of these probabilities and adding it up, you'll get a value of 0.4405. And so your final answer is 1 minus that probability, which is about 55%, 55.95%. That's your final answer. 95%. That's it. That's your answer. Make sense? Everyone? Hope I didn't lose any of you. Cool. That's what I wanted to cover this evening. Any questions? Anything you're not clear about? So what we've covered today is the binomial distribution and the Poisson distribution, right? And how to determine, because remember the question is not going to tell you use the binomial distribution or use the Poisson. It's part of the assessment. You have to figure it out. Thank you for the feedback. I really do appreciate that. Thanks everyone. Okay, so I hope this session helped. But yeah, if there's anything not clear when you watch this recording again, and if something is confusing you, please let me know. But that's all I wanted to cover this evening, and thank you for joining. And have a good evening.